Hello and welcome to the next video in our mole calculation series. What we're going to be looking at today is we're going to be looking at concentration calculations. In particular, we're going to be looking at calculating the concentration in grams per decimeter cubed, in moles per decimeter cubed, and also how we go from grams per decimeter cubed to moles per decimeter cubed. Now, before I start talking about all of those, we've got to talk about an important thing and an important conversion, which is decimeters cubed to centimeters cubed. Okay, and back again. Okay, how are these two linked with one another? Because what you'll notice is that each of these units that I've talked about up here, grams per decimeter cubed, moles per decimeter cubed, they have this decimeters cubed. So one of the things they'll do in questions is they'll give you the volume in centimeters cubed, and you've got to convert it into decimeters cubed. So how do these two relate? Well, a decimeter cubed, so 1 decimeter cubed, is equal to 1,000 centimeters cubed. So if we're looking at doing conversion, okay, of having our decimeters cubed, if we wanted to go to centimeters cubed for whatever reason, okay, we would have to times by 1,000. Okay, 1 decimeter cubed would equal 1,000 centimeters cubed. If I wanted to go from centimeters cubed to decimeters cubed, I have to divide by 1,000. So if I had 2,000 centimeters cubed, that would be 2 decimeters cubed. Keep an eye out for that in the questions that I ask you later. Let's look at the first of these calculations. Grams per decimeter cubed. So what does grams per decimeter cubed mean, and how can I visualize this? Well, it's the number of grams per decimeter cubed. Okay, so this is simply the calculation that you need to remember. If you're looking at the concentration in grams per decimeter cubed, okay, this is what you need to use. Okay, so let's say I've got an example. Okay, I've got some sodium chloride, NaCl, and what I've got is I've got 10 grams of my sodium chloride in 5 decimeters cubed. Okay, question is, what is the concentration in grams per decimeter cubed? So using this example, what I would do is I would take 10 and I would divide it by 5, and that would give me 2 grams per decimeter cubed. Okay, and that is my answer. What about the next one here? Concentration in moles per decimeter cubed. Well, the kind of question that you might get here, okay, is similar to this. Okay, this time we're looking at moles per decimeter cubed. So all that means is it means my moles divided by my decimeters cubed. So this is the calculation that I'm interested in here. So again, let's take an example with my sodium chloride again, NaCl. Okay, so this time let's make it slightly different. I've got 1 mole in 4 decimeters cubed. Okay, my calculation is now going to be 1 divided by 4, which equals 0.25 moles per decimeter cubed. Now, a quick comment on this. You'll notice that I haven't left it as fraction. Okay, we write concentrations as decimal numbers. Okay, so it would be 3 significant figures or whatever's appropriate. And if by magic, here's a couple of questions for you to have a go at along this kind of trend. So these two questions, okay, are just basic calculations, okay, for grams per decimeter cubed and moles per decimeter cubed. Just bear in mind, I've given the volume in centimeters cubed. So think about the first step, okay, that you'll have to do before answering the question like we've just done in the 2 examples above. Okay. Pause the video, have a go. So hopefully you found those okay. Let's have a little look at these 2 questions then. So first off, part number 1, okay, which I'll do in this dark green colour. Okay, so part number 1, okay, we've got 15 grams in 3,000 centimeters cubed. So the first step, okay, is that we've got to turn this into decimeters cubed. So I take 3,000, dividing it by 1,000, and that means I've got 3 decimeters cubed. Okay, I now know I've got 15 grams in 3 decimeters cubed. So I can do my next part of the calculation, which is 15 divided by 3, which equals 5 grams per decimeter cubed. Okay? and it's sodium chloride, so of NaCl. Part number 2, let's do part number 2 in, let's go for purple. Yeah, let's do a different colour. So part number 2, okay, we've got 0.5 moles of sodium chloride in 100 centimetres cubed. So again, the first step, okay, that I'm going to do is turn my centimetres cubed into decimeters cubed. So I have 100 divided by 1,000. Okay, and that equals 0.1 decimeters cubed. So now I just do the calculation as above. Okay, I've got 0.5 moles, so 0.5 divided by 0.1, which gives me the answer 5 moles per decimeter cubed. So let's have a look at how these questions can get a little bit more challenging and just this interconvention between grams and moles and what might be the sort of most difficult question you'll come across. Okay, so what we've got here is we've now got 2 grams per decimeter cubed of sodium chloride, and we want to know this in moles per decimeter cubed. So what we need to do is we need to use our knowledge of mole calculations here. Now, hopefully you can all remember, okay, from one of the first videos we did, okay, that moles equals mass divided by the molar mass. Okay, we talked about that calculation. We talked about a little bit of the triangle that you could use there. Now, what we've got here is we've got grams and we've got moles. Okay, so how do we go from grams to moles? Well, we're going from mass to moles, so we need our MR. Okay, that's what we need. We need this value here, okay, the MR. So if we look at this example, here we've got 2 grams per decimeter cubed of sodium chloride in moles per decimeter cubed. We've got 2 grams. So we know that if we were to write moles, okay, it would equal 2 divided by the MR. Now the MR of sodium chloride is 58.5. So you would type that into your calculator and you would get a really, really long number. Okay, so we would write that number to 3 significant figures. And the number is 0.0342 moles. Now, interestingly here, because we're going from grams per decimeter cubed to moles per decimeter cubed, we can just convert this number straight across. So actually, our concentration is just going to be 0.0342 moles per decimeter cubed. Okay, and that's it. So we've just got to convert that grams into moles. So if we have a question like this, that's all you have to do. Just use this calculation from earlier in the videos that we have done. Okay, so what's sort of like the most difficult style of question that you might come across? So the most difficult style is going to be one like this, where they give you a mass, okay, in centimeters cubed. Now, it's not necessarily more difficult, there's just more steps that you need to be able to sort of follow. So let's talk through this example here. So step number 1, okay, will be to turn my centimeters cubed into decimeters cubed. I've got 4,000 centimeters cubed, so that's going to be 4 decimeters cubed. Step number 2 is to simply turn my mass into moles. So I would take 58.5 and divide it by 58.5 because that is the MR of sodium chloride, and that would give me 1 mole. And now you'll notice this is pretty much exactly the same as the question that we had earlier, okay, where we've got 1 mole in 4 decimeters cubed. So when we're trying to work out what the concentration is in moles per decimeter cubed, we just take 1, divide it by 4, and it gives us the answer of 0.25 moles per decimeter cubed. Okay, so that's how to do those types of questions. I'm going to give you 2 more questions to have a go at, and then that'll be it for this video. As if by magic, mark number 2, here are some questions for you. So what I'm going to ask you to do is I'm going to ask you to work out what the concentration is in moles per decimeter cubed to 3 significant figures of the following 2 questions. 10 grams of hydrochloric acid, okay, in 250 centimeters cubed, okay, and 24 grams of sulfuric acid in 500 centimeters cubed. I've put over on one side the relative atomic masses of the different elements that you'll need to complete these calculations. So, have a go. This sort of brings in a few of our different mole calculations that we've done in previous videos, but hopefully you find it a piece of cake. So, best of luck, pause the video, have a go. So how did you find those? Okay, some interesting use of your calculator would have been required, but hopefully you managed to get the right answers. So let's talk through these questions then. So first off, the 2 steps. Okay, first step, work out our decimeters cubed, then work out our number of moles, and then we can do our calculation. So here we've got 250 centimeters cubed. Okay, so 250 centimeters cubed, okay, is going to equal 0.25 decimeters cubed. Okay, because we're going to divide this by 1,000. Okay. Next up, we've got to work out our moles. Now, in order to work out our moles, the first thing we've got to do is work out what the MR of hydrogen chloride is, HCl. Okay, that is going to be 1 plus 35.5, and I would have used the data over the far side, which equals 36.5. So now I can work out my moles. So my moles of HCl is going to equal 10 divided by 36.5. Now, this is where we've got to make sure we keep the calculator values right to the end. So what you would have got is you would have got a long number. Now, I am going to abbreviate that number ever so slightly. Now, I'm going to round that number, okay, but it was slightly longer than this. I've rounded it up. You should use the calculator value all the way through. Okay, so what I've now got is the final step of the calculation, which is to take my moles, which is 0.27, well, it was 2738, I believe, long number, okay, divided by my 0.25, and it gives me the answer of 1.095, which carries on as well. Now here we've got to make sure we give our answer in 3 significant figures. So turning this answer into 3 significant figures is 1.10, okay, moles per decimeter cubed. So remember, okay, these values here, it's really, really important, okay, that you are using the calculator value throughout. Okay, do not round until the end, okay? Okay, it's very important that you do just that. Okay, what about the second example? So in the second example, we've got 24 grams of H2SO4 in 500 centimeters cubed. Okay, same steps. So my first step is to turn it into decimeters cubed. So I take 500 and divide it by 1,000, which gives me 0.5 decimeters cubed. Step number 2, okay, I've got to work out my MR of my sulfuric acid because I need that. So this is going to equal 2, okay, because I've got 1 for each hydrogen, plus 32 for my sulfur, and then I've got 16 multiplied by 4 for all my oxygens, okay, which gives me the grand total of 98. What I can then do is I can then work out my moles of H2SO4. Okay, and I can do that by simply taking my mass, which is 24, and dividing it by 98. And again, we get quite a long number here, okay, which I'm going to sort of round, but again, this will be your calculator value. So then, last little step, we take our value, we divide it by our volume, which is 0.5, and again, we get a really long answer, okay, 0.487, and so on and so forth, which we're going to put into 3 significant figures, which is 0.490 moles per decimeter cubed. Okay, so a little bit challenging on the calculator front, but the actual working should have been nice and easy, I hope. Okay, if not, rewatch the video and have another look through. So in summary, what we talked about in this video, we've talked about how to do concentration calculations. We've talked about how to work out concentration in grams per decimeter cubed. We've talked about how to work out concentration in moles per decimeter cubed. and we've also talked about how we can sort of convert between the two. How do we go from grams per decimeter cube to moles per decimeter cube? And these two questions at the end is essentially bringing all of that together in some more challenging questions that you might get in your exams. So, thank you very much for watching. Please like the video. If you haven't already, subscribe to the channel. Your support is greatly appreciated. But as always, I will catch you in the next video.